Good morning, students. Our today's topic is heating effect of electric current. In the previous class, we deal with the combination of resistance, series combination as well as parallel combination. Today, we deal with the heating effect of current. When electricity passes through a high resistance wire like a nichrome wire, the resistance wire becomes very hot and produces heat, and this is called heating effect of current. So heating effect of current, regarding heating effect of current, there are several things. Firstly, we deal with the Joules laws of heating. Joules laws. This Joules laws actually consist of three laws. First one, heat produced is directly proportional to the square of the current flow. Heat produced is directly proportional to the square of the current flow. That means greater the amount of current flow, greater will be the heat generated. Second law, heat produced is directly proportional to the resistance. That means greater the resistance, greater will be the heat generated. And third one, heat produced is directly proportional to the time of current flow. That means more the current flow through the circuit, more heat will be generated. These are the three laws regarding Joules laws of heating. So, by the combination of this law, by the combination of this law, we can easily write that H varies I square R T. We are combining the three laws. So for removing the Weiss sign, we have to put a constant term over here, and equation will be like this: H equal to K into I square R T. Here K is a constant. Now if K is equal to 1, then H is equal to I square R T, and that is the mathematical expression of heat generated according to Joules laws of heating. Now, our next topic is expression of heat produced. How heat produced is to be expressed. We know that potential difference is equal to work done by charge transferred. We know that work done here, potential difference equal to work done by charge transferred. So work done is equal to V into Q. Here V stands for potential difference and Q stands for charge transferred. Now I is equal to Q by T. Rate of flow of charge is called current. From here we get Q, that is equal to IT. So work done W is equal to V. In the place of Q you write IT. So we get W equal to V into I into T. Now V should be replaced. V should be replaced. See, we get W is equal to VIT, right? Now, by Ohm's law, we get V is equal to IR. So putting the value of V, that is V equal to IR, in equation first, we get W equal to IR into IT. So the equation will be like this: W is equal to I square RT. So work done is equal to I square RT. Now, according to work energy equivalence, we can say work done is equal to energy, and here the energy is nothing but the heat energy. Energy is nothing but the heat energy, and heat energy can be expressed as H. So H is equal to I square RT, and that is a mathematical expression of heat produced. So till now we have discussed about the Joules laws of heating. Till now we have discussed about the Joules laws of heating and expression of heat produced, that is H equal to I square RT. Okay, now I repeat, heat produced in a wire is directly proportional to the square of current, resistance of the wire, and time for which current is passed. Now, applications of Joules laws of heating. There are several applications. Firstly, we deal with the electric fuse. Electric fuse is the apparatus based on Joules laws of heating. It based on Joules laws of heating. So what is electric fuse? What is electric fuse? It is a safety device. Joules laws of heating is a safety device used to protect our domestic appliances from being damaged. Okay, so electric fuse is a safety device which is used to protect our domestic appliances from being damaged. Now, how the fuse wire or how the fuse, electric fuse works? Before discussing this, we must know about the fuse wire. Firstly, you must know fuse wire is not a copper wire. It is the alloy of lead and tin. Fuse wire is made up of the alloy of lead and tin, and this alloy has some special characteristics. Now the question is, what are the characteristics of fuse wire? See, fuse wire has high conductivity. High conductivity. Okay, this is the first thing. Second one, it has low melting point. Fuse wire has low melting point. These two are the key features of fuse wire. Now the question is how the fuse wire works. We will explain this thing by taking some example. Say, it is an electric circuit. It consists of a electric bulb. You see, it is a fuse box, and inside the fuse box, fuse wire is kept. So there are three types of wires. One is fuse wire. It is made up of the alloy of lead and tin. Now the connecting wire, it is made up of copper wire, and inside the electric bulb, tungsten wire is there. Tungsten wire. So this three types of wire has different tolerance. Let us consider, for example, fuse wire, which is made up of the alloy of lead and tin, can tolerate only 5 ampere of current. Suppose copper wire can tolerate 10 ampere of current, and the tungsten wire can tolerate 6 ampere of current. Now what has happened? If in the place of fuse wire, general copper wire is present, then and through the circuit, suppose 8 ampere current is passed, then what has happened? This copper wire easily allow the current to pass through them. So electric current of 8 ampere goes to the electric bulb, and tungsten wire has a capacity or tolerance of 6 ampere current. But 8 ampere current is passed, then what has happened? The tungsten wire got damaged. So this thing is not happened if the fuse wire is used. Suppose we are using fuse wire, it has a tolerance of 5 ampere. Now suppose 8 ampere of current is passed through the wire. So firstly, it enters in the fuse box. There is a fuse wire. It has a tolerance of 5 ampere, but 8 ampere current is passed. Then what has happened? The fuse wire blown away. So when the fuse wire melts, because more the current, more heat will be generated, and it has low melting point, so easily fuse wire blown away. And when the fuse wire blown away, the circuit is breaked and current cannot pass through the circuit, and the electric bulb is saved from damage. In this way, fuse wire works. This is one of the major application of heating effect of current. In this way, electric iron is also based on heating effect of current. On the base of electric iron, there is a base is like this, and you see, and this base contains a coil. This is called heating coil. It made up of nichrome wire, and nichrome wire has a speciality. It has high melting point and high resistance. So when H varies as R and nichrome has a high resistance, so more heat will be produced, and when more heat will be produced, there is a chance of melting of the wire, melting of the heating element, but it has high melting point, so it cannot melt, and electric iron can do it work perfectly. So these are several applications of the heating effect of current. Today is this much. In the next class, we'll deal with the next topic. Till then, thank you.